Okay, so I want to finish up what I think is the last piece to this distance network calculation that we were doing on GIS. This is part two, um, and these are the results of the part one showing. And I'll just describe it in a little bit of detail just for review. But we took the road network from the census, which is right here. I've put it back on the map, showed it transparent with the categories that come with in the attribute fields. Looked up the metadata and actually labeled them. So you can see the attribute, the symbology here. Like here's the U.S. road, U.S. route, and there it is. It goes right through the center of the county right there, and some more of the state routes, county routes, and then it gets farther out. They start getting into the county, and then there's the light yellow, which is most probably private or not, obviously not categorized in this case. But the raster that we have developed here is mileage based on these roads. And these contour lines that I have created from the raster are based on 5-mile intervals. So I just think it's a really cool map, because as we mentioned before, we're looking at it in terms of calculating distances from this point right here, which in the fictitious scenario is a dump site. And we're doing a debris mission here, and this is one of the dump sites. So we're calculating distances from and to there based on these roads. And I can tell you, I've done the research, and it's different. I mean, there's tools on QGIS that let us use some public available, what do they call them? Let's see what they're called. Online routing mapper. So if I bring this up and try to do the routing with these APIs and tools, it doesn't necessarily match, because these try to route you, to the major highways and not through residential neighborhoods. But in this case, I can tell you that all these roads are being utilized in the shortest distance. So in that manner, I really think it's a better method, and probably more accurate. If we was doing mission recovery of some type and calculating distances, we would be using all these little bitty roads. In some cases too, we have to worry about access, and the access might not be there. So we can actually, in the layer, actually create that type of scenario by breaking these line segments and showing it. So I think this is great, but I want to show you what we're going to do with it, because we're going to calculate distances to all the structures that Microsoft has provided to the open source community. I have here basically all the structures that are in Kentucky, and these are out on GitHub. You can go out there and download those. Great resource. I mean, to start with structure footprints, and have those for your GIS data source. I think that's a great thing that Microsoft did. So what we're going to do is calculate distances to every one of these in Floyd County. So let's get started. I did some notes here, and the first thing we want to do is just select the structures that are in the county. So I'm going to copy this command. I make these cheat sheets because it just makes it a little bit easier. And I paste these in the toolbox because it allows you to filter it and go directly to the command. There's more, as discussed previously, there's more commands in this toolbox than there are up on these menus. And you need to get used to looking at these things and figuring out how to use them, because it's pretty powerful. So we're going to use this select by location. So we're going to pick the structures which are in the layer called Kentucky. I'm going to have it intersect with our county, and all it's going to do is create a new selection. So I'm going to hit run. All right, so that's it. So here's what it did. Of course, we're going to highlight this, But it tells me down here that I have 21,930 features selected. Now, I didn't see it actually any kind of graphic indication that these are selected. And but I trust that this is going to work. So my next command, now that I have a selection set, is to just calculate centroids for all those selected structures that we have. I mean, this is the most direct way, and that's what I want, because eventually I'll probably make a tool out of this that does it even quicker. You know, I've done it in a two-part exercise and video, but what I'll eventually do is create a tool that says you have these layers, we're going to create some centroids from structures with all the mileage on them. So I'm going to use this one, this tool, centroids for Kentucky, and here's the key, and I wrote this in my note right here: selected features only. So we want to make sure we choose selected features only. We're not going to select this because that does a different thing. And I'm not going to worry about putting a file name on here right now. I'm just going to go ahead and run it. So I'm going to turn these off, and now what are we going to see? Points for all those structures in Floyd County. And that's awesome. And you know, there's no attributes on them. They just have a unique ID number, and there's a bunch of them. And we know there's 21,930. And that many distances, you know, from this center point or start point measured is just phenomenal to me. I get so tickled about these tools. It's just exciting to be able to provide this kind of information for decision making. So what's our next step? Next step is we want to add the raster values to the points. And what that does, since the raster value is based on miles, there'll be a unique ID with the mileage put on it. And even if we don't want to create a map, that type of tabular data could be used and passed around and given to people and used in multiple different ways to make decisions, and in this case monitor and calculate cost based on these debris missions that we're working on. So here it is, add raster values to points. And look how easy this is. We got our centroids. We're going to select our raster here. In this case, it's the IDW county. For those who haven't watched the first one, the IDW is basically a interpolation method that we use to develop the miles distance raster layer. Now the interpolation, I mean, there's a lot of different ones here, and there's nearest neighbor, which is very popular. I'm going to just use the bilinear because it does a little bit more checking on the surrounding raster. So that's it. I'm going to run it. And we're going to end up, like I said, with a set of point values for all the structures in Floyd County, Kentucky, with a distance from that start point. I just think that's so powerful. Is it done? I think it's done. Oh, no, there it goes. It's still going. Ah, it's done now. Task complete. So now we got a new layer. Looks the same, but here's what the difference is. If I open up the attribute table, this is distance in miles. So, and that's pretty awesome. So I'm going to turn that off for a minute. I'm going to zoom in here to a little bit closer so we can see it in a little bit more detail. I'm going to turn the structures on. So look at all these structures in there. Let's look at this area right here a little bit closer. Then here's the centroids to all those structures. You can see those. So each one of those, I'll show you. We'll turn on the label, and we're going to tell it to use the single label, and we'll use this field IDW county because that was derived from the raster, and the field is just named automatically based on the raster name. But we know it's miles because that's the way we calculated it. So we've got the text here. What am I going to do? I want to format it. I don't want all those decimal points, so I'm just going to make one decimal point. I'll put a little buffer around it too so we can see it pretty good. And let's make it, what size? It's 10 points. Let's go with that. There we go. So every one of them has a distance now. And I think that's pretty amazing. And, you know, I just pull out and look at it again. Because that's a bunch. Over 21, almost 22,000 structures now with road distances from this start point. You know, the wonders of GIS. And what's even more amazing to me is that this is free software. Go out there and get it and have you some fun.